Lists are the workhorse of Python. You will probably never see a Python program of any complexity that does not use lists. We introduced these lists last week, but we showed them in their most basic form. We showed fixed length lists. You could access them, you could modify them, but that was about it. Today we're going to talk about some more of the capabilities of lists. You can actually dynamically add and remove elements to a list so that its size changes while your program executes. There are a lot more methods to lists as well, but we're going to show a few today. We're going to show the ones that you need for this class, but I encourage you to look at the documentation and learn about the other features of lists. With that, let's get started. Okay, so let's take a look at what we can do with lists. Right, so I can create my list here with the brackets just as we did last time, and let's put 1, 82, -6, 4, 3, and 8 in my list. Okay, so I have a list, I can create it this way. I want to talk about some additional methods. We know how to access elements, right? If I want to, print lst2, oops. That's a bracket. We know that what will happen is we'll print -6. I know that I can get to the last element. I can print lst -1, get to 8. But what do we do if we want to do something else and something more interesting? I want to talk about two methods that allow us to examine things inside a list more easily. That's in and index. So what do these things do? In allows me to check if something is in the list, as the name kind of implies here. So I can write statements like 82 in lst. And this will evaluate to H or Z. Now that was just checking if you guys were paying attention in previous lectures. It will evaluate to true or false. Okay, so in this case, 82 in list, well, here's 82 right here. That's going to evaluate to true. So I can write statements like if 4 in lst print 4 is there. Okay, so you can do checks like this. Right? Index gives me a little bit more information. This just tells me whether or not it's in the list. Index tells me where it is in the list. So I can write statements like, let's say, lst.index 8. Okay, and what this returns is the location in the list. So we've got 0, 1, 2, 3, 4, 5. This is going to return 5. Okay, I could similarly do list.index, should spell it correctly, okay, 4, and I will get 3 returned. Okay, so in and index give me more information about the contents of a list. I can figure out if something's in there, and if it is, I can figure out where it is in that list. Now that's interesting, and that gives us a little bit more capability beyond just looking at individual elements of the list. And it allows us to use lists for additional things where I can check for membership. Still, I'm stuck with my list being fixed size. So I want to talk about two additional methods, append and pop. And this is where things really start to get interesting. With append and pop, I can now change the list. Okay, and we saw how I could change it before by just changing an element. So I could say something like list bracket 2 equals 5. Okay, that would go through. That would come over here. That would actually get rid of that. It would replace it with a 5. Okay, and that has changed the list. Append and pop are a little bit different. I can now say list.append 632, and what this does, you'll ignore that craziness. My eraser works. I can actually now add 632 to the end of the list. My list grew. My list got longer. And I can put a sequence of these appends. I can make it as long as I'd like. I can also call list.pop. And that actually now removes that last element. So my list will go back to looking like this. If my pen would work, here it is. Okay, so That removes an element, so I can shrink it, and I can shrink it back down to 0 elements in there if I'd like. List.pop actually returns something, and what it returns is the element that was popped. So in this case, it would return 632. So with sequences of appends and pops, I can change the size of a list. Within an index, I can find things inside the list, or find whether or not things are inside the list. Now, if pop only removed from the end, it would be a little bit restricted. So pop actually takes an argument. The default is the end, but I could say list.pop 4, and that would remove the element at location 4. 0, 1, 2, 3, 4. So rather than erase it, I'm just going to scratch it out. Now that's gone. Okay? All right, with these methods, I can do a lot more with lists. And as I said before, there are additional methods that I can use on lists, and I strongly encourage you to go to the CodeSculptor documentation and explore them. So let's look at these list methods in action. Let's see what we can do with lists. And I want to use a task manager as a simple example of how to do this. So here's my little task manager. I have an empty canvas right now. I have an input for new task. I have an input that allows me to remove a task by number, and I have an input that allows me to remove a task by name, and a little button that clears everything. And you can see the code over here. I've hidden most of it, and I'm going to reveal it as we talk about it. Okay, so the new task, what happens here? I start out with a global variable, tasks, that has no tasks in it. And you can see over in my canvas, no tasks are being drawn. So let's add a task. What kind of task might we have? All right, what do I need to do today? Well, I need to teach Joe how to play Pong. Okay, there's my first task. All right, and you can see I'm going to ignore the draw handler for this entire lecture. We're going to talk about that in the things that are needed for that in the next lecture. But for now, it draws the tasks that I've added. Teach Joe how to play Pong. All right, let's add another one. Let's say buy some ties. I feel like my tie collection is getting a little light. I need to go get some more. Okay, I can add that in. Now you can see it's adding things. So what actually happened? Let's click over here to new. Okay, this is the event handler when I enter something into that input box. We can go down here, the new task calls new. It's real simple. Okay, no matter what I typed in that task box, all it does is call tasks.append with the message. And so this list is growing as we use the to-do list or the task manager. Okay, that's easy enough, right? So I could keep adding, lists here. Don't forget the colon. How about find missing rice owl? Okay, so now I've got a bunch of tasks. I would like to be able to remove them as well. So I have my remove by number box here. So I say, well, I remembered the colon. I don't need to have that tasks anymore. There, it's gone. Okay, so I can type a number and my task will be removed. There's a hopeless task on here that really I just, it's never actually going to happen. I'll be able to beat him forever now. Okay, all right, so I can keep doing that, right? And my list shrinks correctly, and when it redraws the task list, only the tasks that remain happen here. So what does remove num look like? Well, first, remember the input boxes, you get a string as the argument, so task num here is going to be a string. I convert it to an int with the int function. Now n is the number of the task. You'll notice that I numbered my tasks 1, 2, 3, 4, 5, etc., but in Python lists are indexed 0 and so on. So I want to check that this is actually a valid task. So it's got to be greater than 0, it's got to be at least 1, and it's got to be less than or equal to the number of tasks that are currently in the list, or len tasks. And if it is, then I'm going to call task.pop with n minus 1. Right? I got to do n minus 1 because I'm trying to remove task 1. I'm really removing the 0th element of the list. So there's remove number. Okay, I've also added a way to remove tasks here. You may not have noticed, but I really quickly jumped out to the store during this video while we've been talking and came back. That's the magic of being able to use a video camera and cut things and paste. So I don't need to buy some ties anymore. I got a bunch of ties that you'll be seeing later in the semester. And that's gone too. Now how did I do that? Let's look at remove name. Okay. Well, I'm using in. So if the name of the task is in the task list, so task name in task list, then I'm going to remove it The remove method, which I didn't talk about, okay, I told you should look at the documentation. There are many interesting methods, and I'm just doing this as an example to show you one. Remove takes an element, it looks for it in the list, and if it finds it, it removes it. If it doesn't find it, it's an error. So I had to do in here first. Okay, so my simple task list here has demonstrated to you the use of append, right? It's demonstrated the use of pop. It's demonstrated the use of in. And I added remove here instead of index. Now hopefully you could understand that I could have written this tasks.pop, tasks.index, task name, right? Then this would have figured out the index of that task because I know it's in there because the in was evaluated to true, and then I can pop that index. Okay, so I encourage you to look at this program a little bit more carefully, expose some of the functions that I haven't exposed here, and make sure that you understand what's going on. As you can see, lists are really quite powerful. Without much code at all, I hope you'll agree that we created a somewhat reasonable looking task list program. The methods append and pop and in and index and so on are very powerful, and this is really why lists are the workhorse of Python. We're going to look at some more examples because I think the simple task list is probably not enough to get you really comfortable with lists, and I think that's critically important to becoming a successful Python programmer.